Hey everyone, my name is Kelvin and welcome back to my channel. So I realized that in the previous few videos, I didn't really do a good job of explaining the goal of what this application is trying to do. Previously, whoops, this needs to happen in the background. As I was saying, the goal of this application is, as mentioned, kind of inspired by the anonymous message board on FreeCodeCamp, but essentially what this is a clone of 4chan, or one of those old image boards, where we have two main resources. We have threads and replies. And it's not CRUD exactly because the D is different. So we're still doing create, read, and update, but we're doing a soft delete. So if we scroll down here, there's all these properties that we need on our data models, but doing a put request is gonna generate a flip of the reported value. So this reported value is a boolean and we just need to change it from false to true. And the delete, which is a soft delete, we're actually doing an update and we're changing the text to deleted. And this happens on both the replies and the thread. And one of the reasons why I chose this project specifically is because of database relationships, because that can be tricky, so I wanted to cover it. And it's kind of a good thing that I'm explaining in this video because we're going to start doing what is called the business logic. So as mentioned, we're doing the MVC architecture, so model view controller. And the name is a bit of a misnomer because the idea is that we're separating each layer of data based on its responsibilities. And the controller was what used to be where all of the business logic happens, but that's actually now been moved to a service layer. And the controller is now the view layer, which is what we send back and forth to the HTTP part of our application, or the JSON view, if you will. And in this video, we're gonna be mainly concerned with the domain of threads. And those are just some fancy words saying that we're gonna deal with the resource of threads, so the domain. So that means we're gonna do the thread service and the thread controller. And then also, just to touch up, we're still using the provider pattern. So we're gonna be providing the database connection, which is over here, into the service, and then we'll inject or provide the service into the controller. Hopefully I explained that well enough, but let's get started. First, we'll need a directory called services, and we'll make a thread service.go. Make sure that we add our package, and following the same pattern, we're gonna have a thread service interface that's publicly available, so capitalized, a private thread struct, so this one's gonna be lowercase, and a constructor method or function that'll return the interface of thread service, which is actually the private thread service struct. Now the first thing that we want to do here is make sure that we add our provider or inject the correct dependency. And what we want here is going to be our database connection, but inside of our thread service struct, we actually just want the raw GORM DB. And we could get that by doing connection.get. And just to double check, I'm going to open up the database connection file and make sure that we have this method fulfilled. Once that's done, I think we can just go back to the main file and instantiate this service just so we don't have to think about it or come back to the main file until a little later. Now this needs the connection. To make sure that this compiles, I'm going to change the print line to print out the thread service. Alright, let's go back to the service and stay here for a while. Let's start with creating a function that's attached to the thread service called list. And what we want to do here is grab the DB and do a find. And then ultimately we want to return the result, but there's a couple of other steps that we need to do. The first one is to create a variable that's a slice of threads or models.threads. And that's because GORM needs to know what we're trying to find, and it'll bind this variable with the result data. And the result data is just going to be inside of T, so we can return T. And what we want from the actual result that we're assigning here is the error. So here, since we're returning two values, we need to add the return type as error and a slice of models.thread. Now doing this will return all of the threads, but for pagination, we'll need to do offsets and limits. The limit just means how many are coming back, and the offset means from what point in the list we're starting from. In terms of our controller's perspective, we don't want to expose all of that implementation details. Instead, what we want from the controller is the page number. So that way we'll have to calculate the offset ourselves, which is 1 less than the offset, and then if page number is 0, then it'll just be 0. And because GORM is a really good ORM, we can just feed it into the database builder, query builder here, by using the offset method. Now this query is gonna get a little long, so I'm just gonna put each chain method on a new line. And this is kind of Go specific, but you need the dot on the very end because the Go compiler is basically adding semicolons to the end of lines unless there's something that says, wait, this line doesn't end. So usually it'll be a comma or a dot. And let's just limit this to 10 per page right now, which is hard coded, but we can change this later if we want, but this is fine for now. And then lastly, we want to order this. Now this piece or fragment or string fragment is raw JSON. So we're just doing bumped on descending. So it'll be ordered by the most recently updated thread first, and then going down from newest to oldest. And that completes the list method. So we need to update our thread service with the function type. So this will be models.thread, and we also need to provide the parameter of page. So that's one way of creating a service where we do the function first and then adding to the service. However, if we want like better type safety, we're gonna invalidate the struct by listing all of the methods that we want, and then we won't be able to compile the program or basically leave this file until we finish everything that we said we're gonna do. So I'm gonna add all of the normals CRUD stuff. So this will be get by ID, which returns only one thread. Oh, I made one mistake. This needs to be a pointer because what we want here is to return the reference of T. What's a way to explain that? Okay, so I think the way to explain that is the find binds all the data to the reference of T. So T here, this variable, is going to be the exact memory address, but we actually want the data inside of that memory address. So we need to return the reference of T back. And because of that, the return type also needs to be updated to reflect that, which means we also need to update that inside our interface. So that's a pointer and that's a pointer. Next is create, and we're still using the error and model return pattern of the previous two. Now here's where things get a little different. Report, we're only going to return an error, and that's going to be the same with delete with password. And the reason here is because we're not going to do an additional find, so it'll basically take a little bit of load off of the database as we're running one less query. So instead of returning the entire data model after it's been updated, we're just going to return a success or true or false based on whether or not an error comes back. And then also, I didn't mention this, but we're doing delete with password here because a little later we'll have a normal delete, but that's not going to be happening in this video, so I'll leave that for now. And then a little syntax explanation. There's a little shorthand. If ID and password are both strings, so in the parameter, you can just add the type to the end, and it'll pertain to every parameter before it that doesn't have a type annotation next to it. So this basically saves you typing another word in your editor, which is kind of nice. Okay, but now we need to implement these 4 functions. So let's go to the bottom and create the first function, which is get it by ID, and this takes in the parameter of ID, which is a string, and we want to return error and a pointer to models.thread. Let me scroll down for some space. So here we're doing the same pattern where we create a variable called T, which will represent our thread, grab our database connection, used first because we only want one to come back, return result.error and the model, or the pointer to, or reference to the model, I mean. And the big differentiation here is when building the query, we need to have some conditions. So we're going to provide the ID from the parameter here as a SQL parameter, and that just takes in the question mark here. We don't have to care about the casting of the types because GORM will do that for us. And that is all for get by ID. Now for create, which takes in models.thread as a parameter. Because we already have a variable for the representation of our thread, we don't have to create a new var here. Instead, we can just call create from the GORM database, pass in the reference to t, and return result.error and t. Now this is where we need to start thinking about password hashing. So I'm gonna get out of Vim here. Let's clear this so it's easier to see. And we're gonna install another package here called crypto, which comes from the golang libraries. Would this be third party or it's second party? Because it's not a standard library, but it's not completely open source or like out there. I don't know. But now that we have this, we could create a utility function for encrypting our passwords. This will just make it so that through the API, it won't be so easy to find a password and just like delete random threads that you didn't build yourself. This file is going to be called password.go inside of a utilities or utils package. And we just want two functions. So hash password and check password. And then hash password, we're going to be using the generate from password from bcrypt, which is part of the crypto library, where we pass in the bytes version of password, or just byte. Yeah, there we go. And we'll send in a salt of 14. I forgot why I chose 14 actually, but we'll return the string and error from hash password, and then we need to be able to check that password. So this function is called compare hash and password. The doc says the hash has to come first, then the password. That means we need to actually provide. And instead of returning the error here, I'm just going to return a boolean. So we're going to check if there is no error. So basically, if we check the password and it matches, we'll just get true or false. I think I may have skipped this. We're casting the string as a byte because the library that we're using needs bytes, but what we want in our application is strings, so hence the utility functions, just to make our lives a little easier. And I don't know why I changed the order of password and hash here and here, but we're just gonna go with it. That's the best I got, I'm sorry. But now that we have our utility functions, let's go back to our service, try to finish this out. So the creates, under normal circumstances, this is gonna be all you need to do. However, we need to change one of the properties before we save it. And that property is the delete password. And what's being provided from the outside of this service is just the intended password. So we'll surround this with utils.hashPassword, which returns the password or an error, and we need to handle that error. And then when we'll do it here, since this function can return an error and the reference, we can return error and nil. And that's also one of the advantages of us returning a reference, or a pointer, is that pointers can be nil, whereas the definitive object or struct can't be nil. It has to be just the empty version of it. And if that's confusing, you can think of it this way: 0 is the empty version of an integer. So I guess you could say the most falsy version or the most falsy value of said struct. But continuing on, the next thing we need to do here before we go onto the create step is just assign the delete password to password. Now for report, and this one's gonna be much more interesting, and that is because we're gonna do a straight return here. Because instead of doing one operation, we're gonna do multiple operations, and we need to do that inside of a transaction. And the transaction takes a function that returns an error, and the parameter is a pointer to gorm.db. And in this case, it's gonna be tx instead of db because it'll represent a transaction. Now, if you're unfamiliar with what a transaction is, it's basically a way that we can run multiple queries against our database. But if any one of them fails, all of the queries that we ran are going to be undone. Very useful when you're doing multiple mutation type queries, so updates and deletes, and anything destructive, so that if it fails, your actual database is still in the same state. But other than the concept of a transaction, everything else here we've done before in this file, like previously. The first is we're doing a find, where we provide the ID that comes from report, and we just want the first, and this returns an error, and we need to check if it's nil. And I'm adding it inside the if block here is because we need to handle that error. In this case is we're just going to return it. Also, because of this if statement block, result word or result variable is block scoped, so we can reuse the name for the next database query here. So tx where, now we're doing an updated on reported and setting it to true. Result.error is what we get back, and we're checking if it's nil or not. And finally, if the transaction goes all the way through all of these if statements without returning, we need to return something. So we're returning nil. Now there is one last thing, and that is because of this update, we need another part of the query builder. So we're using the reference to the original thread model, and this will tell GORM that this is the specific thing that we're updating. Actually, I'm not sure if this is overkill, but I like it, so I'm gonna leave it. Now I'm gonna copy this because, as mentioned, delete is going to be a soft delete, which means it's gonna be an update, which means it's basically gonna reuse the same logic. So we're gonna change this to delete with password, where we need to provide the ID and password. And I guess I could get rid of this now and put it on the end. The only difference here is we need to check if the password exists, or not only if it exists, but if it matches. So we're gonna have another if statement in between the two transactions, where we do check password, which takes in the attempted password, and then the hash password, which is inside of t.delete password. And this already returns us a boolean, so we don't have to do anything else fancy with the if statement. But on our return, we could use the errors package and create a new error, and we could just send in the text of incorrect password. Okay, that completes the thread service, and I believe I need to mention that errors is part of the standard library. So if we go up, it's just this first import here. Now before we move on to do the controller which consumes this service, I want to go ahead and create another file in our utilities package, which will be called errors.go. And we're going to make a utility function that will handle our API errors. And to do that, I'm going to create a struct that will output the status as well as a message of string. And this is the object that we are going to expect whenever we get an error from our API. Now I could put this inside of our models package, but I felt like our models package should only be concerned with the data models within our database. So this is kind of up to preference, but I chose to put it here instead. The first function we'll need is create API error, which will return an int and a reference, or a pointer to the API error struct. And what that int is actually going to be a status code. And we need to take in the raw error so that we can process it. Now we're also going to log out the error, which we could get from error.error. Now to use log, we're going to have to do the import because the named alias of log, and it's actually the Syrupson logres package that we've installed much earlier on in this project. We'll also put that error message inside of a message variable, and this is mostly for debugging purposes, but other than that, we'll return the status code as is and then create the raw reference of an API error. So status is going to be status and message is going to be message. Now the next function is a little interesting, and it's going to be a function called error from, and it's just going to take in the error, but it'll return the same thing as the create API error. And that's mostly because we're going to call a create API error inside of this. But before we implement this, I need to go to the GORM docs, and there's a page for error handling. And if you scroll down, there's a list of errors that you can get from GORM, which will have all of the named variables, or what is this called, enumeration, that you can use. Now you could do a condition for each one, but the one that I want is just error for the record not found. And that's because I want to return a 404 where it makes sense, and then everything else will just give back a 500 error, which is internal server error. And that's mainly because these errors we don't want to expose to the client in most cases, but we do want to log them. So that's what we'll do inside of this new function here. It'll still be inside of a switch case, and that's more for the future us if we ever come back to handle specific other errors from the database. But the one that we definitely want to handle is record not found, and that is where we'll return create API error 404 and then the raw error itself. We should actually change this to HTTP status not found, and then the default case will return create API error HTTP status internal server error. Forget what I said about not sending this to the client. the logging happens inside of create API error, and I don't want to add that here, so I'm just gonna leave it as is. But with these two utility functions, we can go ahead and start on our thread controller. So that'll be a new file under controllers called thread controller, and this will be package controllers. And let's fill in the boilerplate of the same pattern that we've been using. So the interface, the private struct, the constructor method, which returns the reference to the private struct. And as mentioned, this controller is going to consume the service that we created. So we need to add that inside of our struct, as well as provide it into the constructor method. Services, and we'll just add TS. And next, we could add all of the methods that we expect on this controller. Now this is going to be different from what we've been doing before because there's going to be no return. Instead, all of the methods are going to take in a parameter of the gin context, and then we'll let gin handle all of our API request handling methods. So we'll need one for list, get, create, report, and delete. Now you'll notice a few things. These methods are a lot more general than the ones that we created in our service, and that's mainly because the service is the one that's doing all of the real logic, and this is just handling our requests. In a way, this controller doesn't need to know anything about the implementation details. So as a convention, the naming is a lot more general just to give that sense. And now our linter is mad at us because this doesn't have those methods, so we need to go fill those out. Let's also scroll down. So it's attached to a thread controller, and the first one we want is list threads, which takes in a gin context that we named as C. And I'm gonna do the part that's gonna be repeated throughout all of these methods, which is we're gonna call the service method that corresponds to what we want to do, and that will be tc.ts.list. This is gonna take in a page which we haven't defined yet, but we'll do that in a bit. We'll check the error, and if there is an error, we'll call c.json, and inside of that, we'll call create API error on the error that comes back. Not create API error, this is error from database. There we go, that's better. And then if all goes well, we will just do JSON with the status of okay, and then the results of whatever comes back from our service. Now, it's important to make sure that you return after anytime you call the JSON method from the gin context. Otherwise, it'll continue and you'll have a very strange JSON payload in the API, which kind of looks like this. So you'll have two JSON objects, which is invalid because you can only return one object back through the API. So this will be something like success, false, success, true. Also, the different messages is going to be very confusing for whoever consumes this API. So this is the general pattern that we'll use for all of our API requests. Now, the thing specific to list is the page number. By default, it'll be 0, and that's because we're going to check the query, so the query string or query parameter of page. And doing it this way will allow us to not need a query parameter, so it'll be basically optional, but we'll do a check. So if a page query is provided, we could set the page query to the actual page variable that we're using and inserting into our list service method. Now there's a type conflict because page query is a string and page is an int. So to get the correct typing, we can use the string conversion standard library. And the function is a2i, which is a weird name unless you understand that a means alphabet and then I means integer. So it's kind of a very shortened way of saying parse int. But this will be the page query as the parameter. And of course, more error handling. And if you write a lot of Go, you will be writing this if statement so many times. But here we're gonna do a create API error from our utils. We're providing status of bad request, and we'll do an error message, invalid page query parameter. And also don't forget to return here so we could get out of this function without doing the rest of the function. All right, on to the next method, which is get thread. Maybe I should have started with this since this is a much simpler controller method than list, but regardless, we're here. The first thing we need is the actual ID that comes from the route parameter. And we can do that by using param of ID. And if you're confused as where this is coming from, that's because I didn't actually mention how we're gonna create our routes, but it'll be something like API/thread/ID, and then we'll add the colon to make sure that Jin will know that this is a route parameter that we can use as a variable. But that'll be a string, and that's one of the reasons why I used the type of string as our services parameter for getById instead of int, just so we don't have to go do that whole string conversion if statement thing. And then also GORM knows how to change that inside of its implementation details, so we don't have to take care of it. GORM will do it for us. If error not null, utils.error from API, error, return, c.json, HTTP status. This is a post request, so we need to do created and thread, which is the result, and then return. Now I can copy this and paste it here and reuse this for the report method. The only change will be changing the getById to report, but the problem is that this only returns us error, so we have to get rid of thread, which means we also need to change the return type, which we could create another struct, but Jin gives us a way to create a raw JSON object blob by doing jin.h, and I think I said this earlier, but we're just gonna do success, it's true. If it's true, otherwise we'll get the error, which is the same. Now for delete, I could definitely copy this and paste it on the bottom where we only have to change the method name to delete. From that, everything else is the same. And now we're done with our controller. Unless we're not. We're missing create thread, which I'm pretty sure we did. Oh, I messed up. Get thread is not supposed to do that. So this we have to change to status okay. Oh no, that means these two statuses are wrong too. All of these are status okays. Status okay. Alright, now to maintain order, I'm gonna keep it here to create the create thread. Did I call it create thread? Yes, I did. The Jin context. Actually, this is a little different. So it's kind of a good opportunity to explain some stuff. So let's grab this bottom part because it'll be mostly the same. But we're gonna change this to create and this to status created. Okay, so this part should be familiar. Now the new thing is that we need to be able to get the thread model that we can feed into create, and we can do that by creating a variable of our models.thread, because we're going to be calling a method from Jin, so that'll be the context c dot, and we'll do should bind JSON where we provide the reference to t. And once again, I'm block scoping the error here so that we can reuse the variable name of error for the bottom part of our controller here. And before I fill out the if statement, I'm just gonna provide t to create, so everything below the if statement is valid. But what's happening with should bind JSON is that Jin is gonna look through the request body and then match according to the JSON properties to the model. But it could return an error, and it will return an error if the validation is wrong. So basically when a property doesn't match or when there's more or less required fields. And in that case, we need to create an API error. And like the parameter example that we had earlier, this is a bad request. And the error message will be invalid request body. Okay, now our controller is done. We can check by looking at our constructor and seeing no errors. Okay, let's go back to create. I want to check one thing. The should bind JSON will only work as intended if our data model has the correct binding data tags. I'm sorry if that's confusing, but the best way to see this is to show thread. And in the data tag here, we could add more properties for Jin to use. And the one that is necessary or needed by should bind is binding, where we need to put in required, and this adds validation logic to the binding from Jin. Now it's not only the text is required, we also want to make sure that the delete password is required. So we'll also add binding required here, and that should fill out all the missing edge cases for our controller. While we're at it, let's also do the same thing for reply. just the same two properties, so text and delete password, and that will fill out the thread resource as well. There's one last thing we need to do before we can run our program, and that is to register these routes. So let's just open up router.go. We're gonna make a new file, but I'm just gonna add to the interface of router a function or method called register thread routes. And all this will take is the new controller that we created, so thread controller. Now the reason why I want to make a new file, even though our class is still kind of in this file, is because I want a file that kind of just lays out all of our routes so it's easy to see. And it's kind of nice that you could like kind of separate one class struct into multiple files just for convenience of aesthetics, as long as it's in the same package. So package routes, we'll create a function that we could attach to the router called register thread routes, which takes in the controller of thread controller. And there's no return because it's a void function, so we're just gonna mutate the router. Specifically, what we want is a router group /API/threads, and then we can attach API or HTTP methods onto that router group. So for gets, that will be c.listThreads. Now it's important to make sure that you're passing in the function here and not invoking the function like this, because if you take away the parentheses, Jin will add the context into it when it calls it. But other than that, we can do create thread for the post method, get thread for the ID route, and I think it's important to note that we're attaching the ID parameter here to the router group, so it'll just be /API/threads/ID for this third one right here, which is important for both report and delete, as those two will also need the ID. Now the methods here is going to be put for report and delete for delete. Now that this is here, we can go back to router, check our controller, or not controller, constructor. There's no errors here, so we're good to go. Go back to main and do all of the dependency injections. So now we have the service, and that's consumed by the controller of new thread controller, so we'll pass it in here. And then using the router, we'll call register thread router and pass in the controller. And you can kind of see the layers of data happening. We're providing the config to our external library, so our or router is Jin, connection is GORM, then our internal services or stuff is being injected those dependencies. So we create a service which is used by the controller, which is finally used by our main application layer, which is the router. So version 1 of our application is done. All we need to do now is close this, make sure our database is up. So I'm going to use Docker Compose to do that. Then we could go run main.go. The logging seems to suggest that our API is working as expected. We have all of the routes registered, so API threads, and then ID, and then all of the appropriate methods. But of course, we need to test this. So the route is API threads, and we'll just go through the cycle. So list is empty. We make a thing which needs text and delete password, which I'll provide password. We'll do a send. We have the created thing. We're showing delete password. We could hide it, but that would require making another struct and then binding things correctly, and I'm very lazy, so that's what it is. But before we go to the next method, I'm just gonna create a bunch. So I'm gonna click send like a couple of times. Now let's do a get to an ID. So we'll go to 2. There it is. If we do a put, we should see this reported field flipped, or actually we get a success. So yeah, let's go do the get again. There it is, true. And now if we do a delete, we'll get the success true. Go do the get again for that ID. And we are not currently updating the text. So one small bug. If we do a get to everything, we have these 4 all coming back, and they're also ordered correctly by the bump date. So the newest one is on top. So in terms of testing this for the first time, I think we did pretty good. And also here are the logs. I always appreciated the colors from Jin's logger. It's nice. Let's just make that one small fix in the update method, and I believe it is in services. So delete with password, incorrect password. We're actually updating the text to be, instead of true, we want it to just say deleted in brackets like that. We didn't provide a password. Okay, so there's 2 bugs. And that is because I just did a copy and paste for delete in the thread controller. But we need to do delete with password, and we need to provide a password, which comes from another query param of password. This is gonna be password. It would be a good idea to add some error handling here. I believe we want bad request status here. So status bad request with the message of must provide password query. Okay, now that that's in place, we could do another test. So go run main.go again, and let's go to a different one. So I'm just gonna grab ID of 4, and let's do a delete this time. We're not gonna provide any queries, just so we can see the validation error. So it must provide query, which is good. Let's add the query now. Password is password. Now you can also see that the query param happens after the question mark if you want to do it raw like this. Chances are you're using a HTTP client like Insomnia or Postman, so you could also have this option. Now we'll do the send, and we get success is true. But it's only successful if we do a get and the text has changed, which it did. Okay, that was a long video, but I hope you enjoyed this video. We did quite a lot. We went over the entire domain from data model. Well, technically we started with the service, then the controller, then all the injections from the router to the register of routing, and then also a little bit of manual testing. I'll see you all next time.